Okay, we still continue with the same question regarding this information, information that I expanded onto this part about a molecule with the molecular formula C9H10N2. So we want to figure out its structure at the end of the day. So we found out that from the mass spectrometer information, C9H10N2, we realized that we have 6 degrees of unsaturation, and I have suspected a benzene ring and a triple bond. But that's not only the available possibility. It can be a benzene ring and 2 pi bonds. Okay, let's just take this and we'll see which one is which as we go. So now, about the infrared spectroscopy, given this information, right, all you need to focus about is the information which is like especially this peak, for example, and this one, and this peak, because normally the region between 1.5 going back to 400, they call it, it's a fingerprint region. So I'm just going to mark the fingerprint region. So the fingerprint region, okay, so I'm just going to mark the fingerprint region as I indicated here with the arrow from this part to 1.5. But also, as you can see in our diagram, we have some peaks that are sharp, like this peak, for example. I think we can take it into consideration. And also this peak, yeah, we have to take it into consideration, and this one and that one. So the infrared information, it helps us to figure out the functional groups that we are dealing with in our compound. So let's see how we go about interpreting this information. So for this interpretation to be easy, there is a table that you need to familiarize yourself with, and that table is sort of like a guide on how you can read your information. So I'm just going to show you that table that has got values about infrared. So we have 4 regions of the infrared here as indicated. So this information, if you want to verify it, you can find it in McMurray, the 8th edition of McMurray chemistry textbook. So as you can see, we have these regions between 3000 to 4000, where we expect the CH stretch, the OH stretch, and the NH stretch. Then we have this region between 2000 to 3000, where we expect the what do you call it, the alkyne, the carbon to carbon triple bond, or carbon to nitrogen triple bond. So, and we also have this region between it's 1500 to 2000, where we expect the alkene and also the carbon nitrogen double bond, and also the carbonyl group. Like I said, here is the fingerprint region. So it makes work easy to interpret our compound. So as you can see, when we go back to the information that we are given, it's simple. We simply focus on those distinct peaks that we have. For example, here, this peak here, you know, it's just before 3000. It's not above 3000. So we cannot expect the OH stretch. We cannot expect the NH stretch. And also the CH stretch as indicated So what we expect for this peak, it's we expect pardon. Where is that table? Okay, so for this one, let me just make something clear here. Normally, if you have an OH stretch, it's easier to see the presence of an OH stretch. So you will see it as a broad curve. Okay? If it's an NH peak, you see it as a sharp peak, which occurs around this region of the 3000. So in this case, it's clear that you don't have an OH, you don't have an NH. Okay? So what we suspect in this case, I'm just gonna give, because textbooks do differ when they give these ranges. So some textbooks, they give you a range of values to say from 2.5 to 4,000. You expect, I told you, the NH, the OH, and the CH. But in this case, I made it clear that the first two here, you cannot consider these two. Okay? So probably the one that I'll give a benefit of doubt is the CH. Okay? So I'll consider that I have a CH stretch for this particular this. So let's see here this peak at 2,209. What is this peak telling us? So from that table, we could see that from this table we could see that we have this range from 2,000 to 3,000 where we are seeing this triple bond. So this actually agree with this peak. So for this peak here, I'm suspecting a triple bond. Okay? For this peak. So this triple bond, it can be the carbon triple bond or the nitrogen triple bond. So it can be the carbon to carbon, or it can be the carbon to nitrogen triple bond. So we are yet to figure out which one is which. Okay, so these are our possibilities. So just take note of that. Then we go to this peak between this one, okay, 1.5 to 2,000. So this one, according to this table, it falls in this region where it can be the alkene carbon to carbon double bond or the carbon to nitrogen double bond. So we don't have the carbon now in this case. So we have these two possibilities. So we are here to figure out which is which. So this is the key interpretations that we can give. So for this one, I will say it can be the C to nitrogen double bond, or C to C double bond, like this. So this is basically how we interpret this information about the infrared spectroscopy. So remember what I said here. It's a fingerprint region. Most molecules, they give similar stretches, you know, similar, what do you call it, spectrum. So for now, I'm not going to worry much about this, even though I know I have this peak that can be of concern. I'm going to revisit it later, but for now, consider these three. They can actually give us a clue of what we are looking for. So with that being said, so this is what we have regarding the infrared spectrum, the interpretation of this spectrum. So I hope we are following. We are still trying to crack this molecule C9H10N2. So basically now, the carbon NMR and the hydrogen NMR, they are going to give us the clue of the structure of our molecule. So let's stay tuned, check my next video and see how we're gonna go about this interpretation.